Hello, Math 1020 class. Let's do those three problems from section 6.5. Give the equations of any vertical and horizontal asymptotes for the graph of the rational function. Here's the rational function. So let's start off with the vertical asymptotes. Excuse me. So how do you find the vertical asymptotes of a rational function? Set the bottom equal to 0 and solve for x. So in this case, that's really easy. But you don't want to interpret this as a number. This is actually a vertical line that crosses 2 on the x-axis. So the answer is x equals 2. And you might want to make sure that you actually write x equals 2 and not just 2. Part B, find the horizontal asymptotes of the graph. That was part A. Now, horizontal asymptotes, that's where you have to look at the degree of the top and the bottom. Notice that the degree of the top is actually 0 because 3 is the same thing as 3 times x to the 0 power because x to the 0 power is 1. And notice the degree of the bottom is 1. So whenever the degree of the top is less than the degree of the bottom, y equals 0 is your horizontal asymptote. And that's a horizontal line. That's essentially just the x-axis. All right, let's do number 2. Same problem, find the vertical and horizontal asymptotes, but the function is a little more complicated on this one. But let's find the verticals first. So set the bottom equal to 0 and solve for x. Well, notice in this case, probably the best way to do it is to add 36 to both sides and then take the square root of both sides. Just don't forget that plus or minus when you take the square root of both sides of an equation. So x equals -6, comma, x equals 6 are the two asymptotes. And I think they want you to do it in that order, so be a little bit careful. They want you to do the one on the left first. And again, these are vertical lines. So x equals -6 is something like this. X equals +6 is something like this. We usually use dashed lines to represent asymptotes. But let's go ahead and do part B, which is to find the horizontal asymptotes of the graph. And let's go back up to the graph. Now notice the degree of the top is 3, the degree of the bottom is 2. Whenever the degree of the top is bigger than the degree of the bottom, there are no horizontal asymptotes. Let's do number 3. Use algebraic methods to solve the following equation. 2x squared plus 4 over x minus 2 plus x equals 6 plus 12 over x minus 2. So this is called a rational equation just because you have at least one rational expression in it. So what's the best way to solve this equation? Well, multiply both sides by the least common denominator. In this case, it's just x minus 2. If I multiply both sides by x minus 2, it'll cancel it out on both sides. So let's do that. I'm going to multiply by x minus 2 over 1. All right. Now notice in the first term here, the x minus 2 will cancel. So I just get 2x squared plus 4. But it won't cancel in the second one. I'm going to get x times x minus 2. And on the right-hand side, when I multiply those two together, I get 6 times x minus 2. But when I multiply those two together, the x minus 2 cancels because one is on the top and one is on the bottom. I just get a 12. So I end up with a nice quadratic equation with no denominators. Let's go ahead and distribute the x there. Distribute the 6 there. And I know I go fast. That's what the pause button is for and the rewind button. Notice those 12s cancel. And I can combine these terms. That's 3x squared minus 2x plus 4 equals just 6x. So I suppose I want to subtract 6x from both sides, put all the terms on the same side. And at this stage, it looks like we want to factor this thing, probably. Best way to solve it. So what times what is 3x squared? Probably 3x and x. Now what times what is equal to 4? You kind of have to guess a little. How about 2 and 2? If I do 2 and 2, the outer is 6x, the inner is 2x. Can I get negative 8 out of 6 and 2? Yeah, if they're both negative. So let's just double check and make sure we factor that right. The first is 3x squared. That's this. The outer is minus 6x. The inner is minus 2x. And the last is plus 4. So when you combine, it looks like you do get 3x squared minus 8x plus 4. So remember, the next step is to set each one of these factors equal to 0. So set the first one to 0, and then set the second one to 0. Well, the second one's easy. I get x equals 2. On the first one, I probably want to add 2 to both sides, and then divide by 3. So I get 2/3. So here are the two possible answers. Now let me just tell you that it is possible to get extraneous solutions in rational equations. You have to make sure that you're not dividing by 0. If you divide by 0, you have to throw the number out. And I suspect that 2 is probably extraneous. Let's go back to the original equation. Now notice in the original equation, if I try to plug a 2 in there, I'm going to be dividing by 0. I can't do it. So that means 2 is extraneous. We didn't do anything wrong. You just have to check and make sure that these are not extraneous. What about 2/3? The only thing you have to check is make sure you're not dividing by 0. Well, if I plug a 2/3 there, it's not a 0. If I plug a 2/3 there, it's not a 0. So 2/3 is good. 2/3 is the only non-extraneous solution. By the way, I do want to say one quick thing. We are done with the 3 problems. But I noticed that in one problem, y equals 0 is the horizontal asymptote, and that was when the degree of the top was less than the degree of the bottom. When the degree of the top was bigger, and I think that was in a different problem, there was no horizontal asymptote. But a lot of the time, the 2 degrees will be the same. And I just didn't happen to see a problem like that in our problem list of the ones that I had. But let me just make up an example, and I'll show you what you're supposed to do. Consider this rational function. If I had said find the horizontal asymptotes, that's where you look at the degrees of the top and the bottom. Well, notice the degree here is 3, the degree there is 3. If the degrees are the same, you just take the leading coefficient of the top divided by the leading coefficient of the bottom and set it equal to y. Y equals 2/3 would be your horizontal asymptote in that case. So I wanted to do the third case where the 2 degrees are the same, just in kind of a made-up example. Well, that's enough for this video.